Welcome to JC Engineering and Technical Drawing. Today we'll be assembling a truncated single two post by the down pass at the table of contents of each component. So we'll start by drawing our pillar, which is our number one component, and knowing that the diameter of the bottom part of our pillar is 62 millimeter, we'll measure 31 millimeter to my left, 31 millimeter to my right. From our right here is given, we've gotten our horizontal line and then our vertical line. So at this point, I'll call this point 0. So from point 0, I'll measure 31 millimeter to my left, 31 millimeter to my right, 31 millimeter to my left, and then 31 millimeter to my right. And then I'll draw a straight line, an outline. So I'm done drawing my outline. Now from my image, it said from point 0 should move 10 millimeter upward. So I'll measure 10 millimeter, indicate it with a point, and I'll call that point 0.01. Then I'll draw construction line first. Then I'll project my points from line 0 upward. Then I'll do similar stuff to the right. Project upward. So using 0.01, I'll make it an outline. This way. Now, knowing that from 0.01, I said from 0.01 upward should measure 110 millimeter. So we'll take 110 millimeter from 0.01, 110 millimeter, and then we'll call that point 0.02. We'll draw construction line, horizontal line, 0.02. Now, knowing that from our diagram, the diameter of our pillar is 50 millimeters, so we'll measure 25 millimeter to my left, then 25 millimeter to my right from 0.01. Which we've done. So project that line to touch 0.02. Project it perfectly. So touch 0.02. Now project it also the point to hit the line of 0.02. Now we've succeeded in getting that part. Now from our diagram, we find out that there's a distance of at the head of our pillar from 0.02. We'll have a diameter of 36 millimeter, which will measure. So we'll measure 18 to my left, 18 to my right from 0.02. Put a point. To my right also measure 18. Indicate it with a point. Now, from those points which we have gotten, we'll project it to hit a line extension this way. And then from point 2 upward, we'll have another horizontal line. We'll call that point 0.03. Now from 0.03, we'll have 32 millimeter, which 32 diameter. So we'll measure from 0.02. We'll measure 16 to my left, 16 to my right. 16 to my left, and then 16 to my right. Then we join those points together. The points on line 0, the points on line 02 to line 03, we'll join it to the straight line. Also do the same to my right. And then we'll outline the top. Then from our diagrams, we're still on our diagram, from point 0, so we should measure 30 millimeter upward. So from point 0, the bottom part, should measure 30 millimeter upward. Then we should indicate it with a broken line. Probably let it be light, which we've done. Now at that point here, we'll call that point A. Now from point A, so we should measure 66 millimeter upward. So we'll measure 66 millimeter. And then we indicate it with a construction line. We'll call that point A1. Now, given that we have 22 millimeter, then we'll measure from point A, we'll measure 11 millimeter to our left, 11 millimeter to our right. 11 millimeter to our left, we'll put a point. 11 millimeter to our right, put another point. Then we'll project those points to hit line A1, to hit line A1. Then we can outline those 2 points at line A1 and those 2 points at line A. Wow, done with our pillar. And then we move to our block. Now our block is the number 2 image. Now this number 2 image, we have a diameter of 63. So we have a diameter of 63, and then also at the top we have a diameter of 51 millimeter. Now image number 2 is coming from the top. Image 2 is coming this way, 63 facing down, and from the top of our pillar is going directly downward, so that 63 can fit into 62, and then 51 can fit into 50. So all we need to do is that from point 0, knowing that our height is given to us as 14 millimeter, so we'll measure from point 0, measure 14 millimeter. We indicate it with a point, and then we'll draw a horizontal line from that point. Now, given that the total diameter of our block is 76 millimeter, so divide 76 by 2, which will give me 38. So from point 0, I'll measure 38 to my left. I'll put a point, measure 38 millimeter to my right. I'll also put a point. Then I'll project those points upward to meet my constructed horizontal line. Do same to my right. And then at point 0, I'll outline the portion that needs to be outlined. Also, from my projected horizontal line, I'll also outline now. If you cross check, you find that this is 10 millimeter, this is 10 millimeter, it has fit into 10. Now this is 14 millimeter height, this is 14 millimeter. Now this is 63. Automatically this becomes 63 and 62 because it's coming in. So now we have a radius of 3 millimeter, so having a curve 3 millimeter, and then we'll take 3 millimeter at a compass, then we'll create a tangential arc the point of the intersection will join. Also similarly, we'll do the same to our left, creating a tangential arc to touch those two lines. Point of the intersection will join. You can see that the left is perfectly done. So we succeeded in fixing our block. Now our image 3, which is our ring also is coming from the top of our pillar downward. So this 51 millimeter could size into this 50 diameter of our pillar. So now from our point, from this our horizontal point here, let me call this point A2. From point A2, this top line, point A2, you find out that the total height of our ring is 12 millimeter. So we'll measure 12 millimeter from point A2 12 millimeter, get it to the point, and I'll project that point with a horizontal line. Now it says it is having a diameter of 100. So from point A, now you can see over here we've gotten this point here. From that point we'll measure 25 millimeter. We'll measure 50 millimeter since we're having a diameter of 100. Measure 50 millimeter to my left. We indicate it with a point. Also measure 50 millimeter to my right. Then we indicate it also with a point. Now I'll call this point of my left point X. Call this point on my right as point Y. Now, given that we have a radius of 103 millimeter, now using a radius of 143 millimeter, we'll place it a compass pin. I've taken the distance already at point Y. Ascribe an arc, and then bring the pin to point X, or bisect the arc. At their point of intersection, I'll draw my arc to touch both points. I want to make it an outline. And I'm done doing that. Then you can see that since it is 12 millimeter, would project point X to touch line A2, Also project point Y to touch this our line A2, then we'll outline. Also outline the top part. You can observe the way I'm outlining so that when we are sectioning we'll not have any complication. Now we're done with assembling our pillar. So next thing we'll do, we'll assemble our wedge, which is our figure 4, number 4. Now knowing that our wedge is, we're having a radius of, first of all, the height of our wedge is 16 millimeter. So we'll measure 16 millimeter from point A. You can see it's coming, this point here is will be lying on this center line. So from point A, which is this, we'll measure 16 millimeter upward, indicate it with a point, and then we'll draw a horizontal line, construction horizontal line, the way I just did. And then we know that this is, it started from this point here, so we can just extend this. That is this from my point, my both points are 16 millimeter. So now it says we should measure with radius 143. Now using our radius of 143 millimeter, I'll place it at point A. You can see, then we'll scribe an arc on our vertical line, and then at the point of the intersection on our vertical line we draw an arc. You can see we've drawn the arc. Now if you observe, it says the total distance of our wedge is 120 millimeters. So we'll measure 60 millimeters to my left, then I'll put a point, 60 millimeter also to my right, and then I'll indicate it with a point. Then those points, I'll project the point downward to hit my arc, this way to hit my arc, and also I'll do same to my right to hit my arc, this way. So I'll erase the arc extension, and then I'll outline those 2 points together. So I've succeeded in fixing my wedge. So the next thing I'll do, I'll fix my screw. Now what we are going to do is that, first of all, we'll section our object using angle 43 degree. Because of time, I'll section it, and then you look at the video very well, and then you observe the way I sectioned it on your own. I've sectioned this down part. Now I want to section from point 0 to point A at the same component. I'm sectioning using my set screw of 45 degree. So I'm done sectioning this other part. So I'll section my ring. So I've done sectioning. The next thing we'll do is that we'll fix our screw, which is our figure number 5. Now, from the top of our pillar, you can find out that we have this portion. There's a portion here which is 5 by 2, that is 2 mm deep, 5 mm what width. So we measure 3 mm upward from there, measure 3 mm upward, put a point, and then we'll draw, indicate with a what, with a horizontal line. Now, knowing that the distance is given to us from our bottom as 18, so divide by 2. 18 divided by 2 is a diameter, so divide by 2, have 9. So we'll place 9 mm to my left and then 9 mm to my right, and then I'll project those points to touch my line, the top of my pillar, with an outline. So I'm free now to outline the top, and then from our diagram you can find out that they said 6 mm upward from the top, or from line 03. So I'll measure 6 mm upward, put a point, and then I'll draw a straight line. Now this is 6 mm, confirming it. Yes, this is 6 mm. So half of 6 will have 3 mm. So the major reason I'm doing that is because this over here is, there's a curve. So now the distance of this, they say, is 28 mm, which will give me 14 mm to my left, 14 mm to my right. So I'll measure 14 mm to my left and then 14 mm to my right. Then I'll project the line downward, construction line, not an outline, very light. Similarly, I'll do same here. Now using radius 3, because it is 6 mm, so I've divided my 6 mm into 2, which give me 3. So I'll place it at this point. I'll create a point at that line. Then I'll draw an arc using radius 3 mm. Also similar stuff I'll do to the left. I'll indicate the point using the point. Then I'll draw and then I'll join the edge with an outline. Also this with an outline. Then I can erase this top a little. So the next thing I'll do now, the height of my knot here is 15 mm. So all I need to do, I'll measure 15 mm upward, measure 15 mm, put a point, and then I'll draw a horizontal line. Now this is a square knot here, so, and given us that our width of our knot is 15 mm, so multiply 15 by 1.4. So 15 multiplied by 1.4 to give me 21. So I'll divide it by 2. 21 divided by 2 give me 10.5. So I'll measure 10.5 to my left, 10.5 to my right. 10.5 to my left, 10.5 to my right. Then I'll project the points upward. Project the points upward. And then using angle 60°, draw a straight line, invert our set square, also draw a line so we can get the point. We do similar stuff to the right. Then we'll draw a straight line. Then we'll also do similar stuff, invert our set square, and then we'll join. Now using these points, we'll extend our compass to touch the edge, the top of our line. Then we'll draw an arc. Similarly, we'll extend it also to the top of our drawing there, and then we'll draw an arc. Then using 30°, we'll cut this way and then cut this way. Then we'll join the top of our knot this way. Now we are done with the top view here. So the next thing we'll do is that, since this is 15mm, add 15 plus this is 6, we'll add 6 plus 6. Then this is also 3mm because I say 2mm deep, 5/2, so 2mm deep, 3mm upward. Let's say plus 3. That will give us 24mm. So now we'll minus 24mm from 96mm. So say 96 minus 24, which will give us 72mm. So we'll measure 72mm from the top of our pillar downward. 72mm from the top, we'll measure it downward. Then we indicate it with the point. And then we'll draw a horizontal line, construction line, this way. So now the next thing we'll do is that, given that from our midpoint here we're having 8mm upward from this point, let me call this point B. From point B upward we're having 8mm, so we'll measure 8mm upward. 8mm upward. Now indicate it with a point. Then I'll draw also a construction line. Now giving us that the total length of the knot is 18mm, so 18 by diameter, so I'll measure 9mm to my left, 9mm to my right, 9mm to my left, 9mm to my right, and then I'll outline. I'll project those points upward to hit my up horizontal line, which I have constructed. So that hits my up horizontal line. So similarly I'll join. Now you observe that the total distance here, the metric distance here is what? 22mm, which is already this, which is 22. If you measure, you see that it's already 22mm. So we'll project 22mm upward to touch the top part of our pillar with an outline. Then we can erase this portion since it is being sectioned. We can erase that portion, and then we'll join this together. Now from 18, this is the nut and the screw, so we'll section. That's our screw there. So when you are sectioning a screw, you use the conventional, you represent it with the conventional what, a sign. So the conventional sign, you just, it's a broken line indicating this portion here is a screw. And then we're done with that. Then we'll section this portion upward from where you see 96 millimeter, that line, you section it upward using 45-degree set square. And then we are done sectioning. Now the major reason we section this diagram this way is being sectioned this way. So when you cut this stuff here, you can see this side they are all blocks, they are not cylindrical, there's no hole inside. So this is, we'll section it with 45-degree. Now when you are sectioning a screw, you use a conventional representation. That's why we have this portion. And then when you are sectioning, you find out that this hole here, there is a hole at this middle here, there is a distance, a gap. So when you section, you find out that there's nothing here to section. That is why this portion, both portion here, they are not section. Then coming over here, since we've already fixed our wedge into this, it will section our wedge into two, which we got this. And then when you are sectioning it downward, you find out that you section all through downward, you can't see any other lines passing through a section part. That is why all this remains the same sectioning format. That shows that it's a what, same image being sectioned over here. Thank you for watching. I still remain JC Engineering and Technical Drawing. Remember to give me a thumbs up and subscribe to this channel. And then our next video on this same topic will be drawing the end elevation and the top view of this. If you want to see that, don't forget to hit the like button, subscribe to my channel, and then you get a notification when I've done that. Thank you very much. I still remain JC Engineering and Technical Drawing. Do have a blessed day ahead.